The Chinese experimental fusion reactor EAST has set a new record for plasma confinement time, 1,066 seconds. This surpasses its own previous record of 1,056 seconds, set in the year 2021. To create a working fusion reactor, we need to heat fusion fuel, which is a mixture of the hydrogen isotopes deuterium and tritium, to approximately 150 million degrees. At the same time, we must compress them so that the plasma density reaches about 2 times 10 to the power of 20 nuclei per cubic meter. Then, we need to confine this plasma in that state long enough so that fusion reactions release more energy than was spent on heating and compression. For plasma parameters like those mentioned above, the required confinement time is around 5 seconds. The Chinese team, as we see, has achieved confinement times hundreds of times longer. However, they have not started a self-sustaining fusion reaction. And, looking ahead, they never will. First, these long plasma confinement times in EAST were achieved at temperatures of only 75 million degrees, which is twice lower than needed. At actual working plasma temperatures, the confinement times are much more modest, around 20 seconds. Second, the plasma density in EAST is about 50 times lower than what is required to start a self-sustaining reaction. Moreover, reaching the necessary density in the EAST reactor is fundamentally impossible. It is simply too low-powered. No matter how long the plasma is confined there, a self-sustaining reaction will not start. To achieve this, we need more powerful facilities, such as the International Thermonuclear Experimental Reactor, ITER, which is currently under construction in France. ITER is supposed to become the first fusion facility that provides a positive energy output. And when, or if, ITER is completed and launched, if that ever happens at all, then the experience of Chinese researchers in plasma control may actually be useful.